All right, so this demonstration is going to be a redirect URI vulnerability demonstration where it's going to be about the gate that's supposed to stop an auth code from ever reaching the wrong place, which is what redirect URI validation is. And RFC 6749 section 3.1.2.3 requires character by character exact string comparison between the redirect URI in a request and the URI that is registered for that client. So what I'm going to do is I'm going to check out here to my exploit redirect URI that I made. And what I'm going to do now is, I'm going to weaken the check by replacing the exact match with a host name only comparison and show what an attacker can do based on that. So I'm still going to use the two accounts, Alice acting as an attacker and Bob, who is the victim or the end user who does nothing wrong at any point. Yeah, without further ado, let's get in. Let's first of all find authorize.js in our authorized server. And this is currently the safe implementation. Nothing has been wrongly implemented. But what a developer could do is they could forget to do strict character by character checking. And how we can simulate that issue or vulnerability is by going on handle authorize get first of all. Let's just find handle authorize get. Here it is. This is our function. Here's the current check right over here, or let's just highlight all of that, where the current check is if it isn't the redirect URI, or if or this main part, this either matches a pre-registered URI exactly or the request is rejected. But what I'm going to do is I'm going to comment out this line and I'm going to replace that line with the vulnerability. And let's just comment it as well, showing that we are introducing an intentional vulnerability for future reference so that we don't forget or find where it is. And it will be the redirect URI. Sorry, I'm sick still. Hostname only comparison. And the threat model for this as reference is the RFC 6819, and it is 4.1.5 if I remember correctly. And the fix, restore the commented out line before, mainly this part. Below is what I meant. Right. So that's our comment done. Now what we're going to do is we're going to make a constant first of all of redirect URI valid, being the client redirect URIs for some looping, and the sum is going to be the main part of this, not just a loop. So instead of a one exact match, I'm now looping over every registered URI for this client and asking whether any of them is close enough, which is what the .sum function, or the sum function here, does, which returns true the moment one candidate passes. And that's the difference what we're doing, where the previous thing matches it exactly character by character basis, pixel by pixel. But this is saying, oh, if it's close enough, we're going to be doing something. And under here, let's write down our try with a constant of our host names, which we're going to be comparing. And let's just build our host names. The first one being the registered host name, and the second constant being the requested host name, which is some new URL, redirect URI host name. Right? So what this is for each registered URI from above, I'm basically passing it with the URL constructor and pulling out only the .hostname. So, and I'm going to be comparing the two host names later, which I'll do later. And for localhost callback, that's going to be just the localhost part of it, where the port and the path are both discarded. So it's only checking the localhost matching, which means that you can do some funky stuff, like equating local hosts, although the ports are different. That's what I'm gonna get at. Yeah, and then now that I've done that, let's return the registered hostname like that, and strictly match it to requested hostname, checking if they're true, and catch is just gonna be return false, like that. And here we go. This is the actual bug in one line, comparing host names only, and it's gonna be comparing this vulnerability will compare the localhost of our original server 3000, which is what the main page is, and also the localhost of Alice's malicious server, which she will create in a bit. Captcha. Let's name it Captcha and don't forget the naming convention. But yeah, they both have the same host name. And that's the only thing they're checking. They're not checking everything else, and they're not checking the full thing. So if the host names just match up, and a developer could do this because, oh, if it, goes to the same domain, goes to the same host name, then, it's a match, right? That's how they could think of it as, but that's not what it actually is. Or AI could generate it like that if someone's like vibe coding on authorization thing, then this could be a genuine vulnerability that happens where they only check the host name matching. All right, enough yap. Our final line is gonna return the if statement, or not return the if statement, but like add back in the if statement that we commented out. Except that we're gonna leave that part. Instead of the previous character by character check, we're gonna do if not equals the constant we made earlier that only checks for the host names, like so. And let's don't forget that. Yep, no errors are showing. Good, good, good. Boom. And now the condition only checks our loose and redirect URI flag instead of the exact match core. And everything below this line, above this line, everything is the same. Oh, but before we move on, that's not it. Handle authorized get is where we introduce this vulnerability, but there's another place we want to paste the same vulnerability, which is going to be handle post. And the reason why we're going to put in handle post as well is because the post handler's original exact match check down here is still going to check it. So even if it gets through the handle authorized get, the vulnerability will die at post. So an attacker essentially can't do much because this is a handler that mints the code once the user's clicked approve. So the get allows a user to even reach the approve page, or the get vulnerability lets them to reach the approve page in the other domain, but they will not be able to approve properly so that the attacker gets any info, which is why we're going to introduce the same bug and replace this whole line with our copy-pasted vulnerability as above. And there we go. That's the entire vulnerability. Very straightforward. That's it. Very easy to miss for a developer, or very easy for an AI to not implement this as RFC standards. So yeah, this is a genuine vulnerability that has occurred, and can occur in cybersecurity or in security engineering. And let's now build what could be waiting on the other side of this. So let's go to our capture server that we have created under attacker tools. And again, this file is nothing to do with a real client or auth server. It represents an infrastructure that Alice controls on her separate device. And let's document that before writing any knowledge. It was double asterisk, I believe. So this is just going to be Alice's capture server for demo purposes of RFC 6819 4.1.5, which is redirect manipulation. And just as a disclaimer, let's add a disclaimer. This server is not part of auth server or client app, as it sits outside the trust boundary described in the aforementioned threat model, only receiving traffic since the vulnerable hostname only check and authorize.js treats it as equivalent to the real client. There we go. That should be enough. All right, let's of course start with use strict to prevent any global variables from being created, I believe. Just conventions. And yeah, let's start building our port or server. And this is just going to be the same framework as the client, the real client app, for consistency. And like that. Express. Sorry, I'm still sick. And we're just going to make the port 9999. It can really be anything. It just has to be different to 3000 and 3001 because that mismatch is the entire point of this exploit. Alright, and we'll also add the app-get capture, and this naming convention matches the authorize.js thing we had in the comments, where we can send it to the host 9999 capture section. And let's do constant with the code and the state of the token. And we're at query. Yeah, so this captured root matches a path in the malicious redirect URI we will craft in the demo, and pulling the code in straight off the query king. Query string, Jesus. There's no exploit payload in this entire thing. Like, there's no injection or anything. Nothing clever. This is just going to be the server. Because the vulnerability in authorize.js we introduced already did the work of getting the browser to the server, and the root just has to be here to receive it. All right, now let's add some console logs. So yeah, this is just going to log what arrived. Clearly labeling, just for the record. And in a real attack, this would be silent or logged to a database. Wait, hold on. I believe I need to do a backslash here just to make the single quotation not scan, and let's just add a new line. But yeah, in a real attack, this would be silent or logged to a database, but I am just choosing to keep it loud and visible on purpose so that every step of this demo is just visible and not just like an automated action that happens like kind of invisibly. So this code is bounded to whichever account approved consent, which is going to be Bob in this case. And, just add that. New line, another new line, because we want to separate it to what I'm going to add, which is going to be exchange it manually with, and here we're going to add the, I guess we'll just do /n here as well. Here we're going to add the actual command tool, and this is the biggest part of it, which we're going to do. In an actual like thing, we're not going to need any of this, but for demonstration purposes, I'm going to include the commands Alice is going to use on her bash terminal, on a PowerShell terminal, as part of the console log. All right, so let's start off with that. Yeah, what's going to happen is, well, we're going to start off with curl.exe, not just curl. I figured out the hard way. And this is just a command line tool used to transfer data to or from a server over a network. And let's add our post HTTP, the local host 3001, not 3000. That's just a front end part. This is the authorization part. And this token is the destination URL on the local computer where the security server is going to be listening for token requests. And the X flag here is X post flag, I should say, specifies the request method, which here forces a command to use post, which is used to send or submit data to a server. Let's continue. We'll use a H flag of, we'll do content type being application X, and then some link like that. Content type. Yep. And then close that off. The H flag is just the header flag providing metadata about the request, and in this case it will tell the server that the data being sent is formatted like a standard web form submit, which is what this is. And now let's use the D flags, which is going to be the data flags, which are going to be the actual pieces of information we're going to send in the body of each request. And every D flag I'm about to add is going to add a new key value pair. So what that's going to look like is -d grant type equals authorization code, authorization code, and -d again, client. Also, I could do this on multiple lines, like I believe like that for everyone, but for some reason it bugs out when you paste it in my terminal. I'm not exactly sure why. Yeah, let's make a flag for the client ID, equaling just the client app ID. And another flag we'll use is the client secret, of course, equaling the client app secrets. And let's just put quotations around that. There should be quotations around every single flag, except for the capital flags. Yep, what are we missing? I think that's about it. Because we have the secret, client ID, cool. So the grant type, this one tells the server that we're using the specific workflow where a temporary, what is it doing that? Code is exchanged for a permanent token. And yeah, and the redirect URI, which I'll be adding, is going to be a security check to match it directly. What have I forgotten? Oh, actually I've forgotten, yeah, the redirect URI completely. Let's just add that in. We'll do -d and the code, of course, being just the code, and this is the code that will be generated. And then of course the most important part, the redirect URI. And we want to strict match that to our localhost capture server. Like that. And then, yeah, I think that's everything. Yeah, and the code is just the temporary authorization code that we received from the user's initial login. And maybe I'll just leave it as like, you could do like input code here. Input authorization code here. Input stolen auth code here. We could even do that, just so that we can see how an attacker can use like a template of this, basically, like that. All right, let's finish off this program. I added an else statement without an if statement. The if else, not if else. Wow. I all-nighted doing this, so can't blame me. There we go. And now, because we removed the code section from our third console log here in the if statement, we want to add another console log here, just being stolen authorization code. And we want to see what the code is. So we can manually put it in ourselves for demonstration. There we go. Yep, that makes more sense. Alright, let's move on. Well, I think that is it. We have our console. Oh, right, we want to add our status 200 here, and our HTML. Send to, let's just separate this out. Conventions, doc type, what was it? Doc type HTML, and some HTML. This is just what Bob is going to be seeing. I'll explain in a bit once I focus up. We'll just do a default font, sans serif, default padding, base color, And I don't think we need anything else. It's gray. Oh, we want to close off our body. And we want to close off our HTML. Yep, that looks about right. And yeah, this is what this section is just gonna be what Bob actually sees. Not really anything here. Nothing, just nothing that looks broken. And worth noting that once Bob clicks on the link Alice sends him, this is gonna read as, oh, the link didn't work, basically. Which is, yeah, it's not gonna say, oh yeah, you were attacked. So Bob wouldn't actually know you got attacked. Let's actually add that in. Just under here. This page isn't available right now. Sound off like that. This is what Bob is going to see on the page. So he's just going to think, oh, the site's down, or like, oh, okay. Nothing, to be concerned about. But in reality, he's going to be doomed. That's what's going to be happening. Let's just style it a little bit better. Okay, yeah, I believe this is a whole capture server, and this part is not actually needed, and this part also is just, this part is actually relevant for Bob to not report it, because we don't want Bob to suspect anything. Alright, yeah, that's basically it. I don't believe I made any errors. I hope I didn't, because spent like 8 hours trying to figure out everything constantly. But yeah, without further ado, let's run our full attack. And we'll need multiple terminals for this. Alright. So, first off, we're going to go into our SRC, and we want to just run our ports as usual. cd auth server src node server.js. We're going to do the same thing, cd client app src and node server.js. So we're running it on localhost 3001 and 3000. And in our third terminal, we want to run localhost 9999. Let's go in there and we will do node and capture server.js. Like that. Did I do that properly? Hacker tools, hold on. Node, save that. Capture, server.js. Okay, let's do a tiny bit of debugging. Actually, okay, let's make some things clearer before we move on. We can make that capture, and we can also do that here. Capture, get, capture, code being the code. That with the state being the state like that. That's better. I forgot the app listen. That's what's going on. Again, very sleepy. Console log, brain's a bit fried, and I forgot the app listen completely. Alice's capture server, listening on HTTP, localhost, and whatever port it will be. This will just be 9999, but we can do $port so that if we want to update the port, it will just manually update. So that's that. Cool, now it should work. Let's try that again. Perfect. Now it works. Alright, back to the demo. Now we have all of our servers running. And now Alice is going to craft the malicious URL. We'll even just add it in the capture server because this is owned by Alice. Alice's... Or we could even add it in... here, where we want to add another console log. Instead of just a comment. And we can write... we can write the link that Alice is going to craft, which Alice is going to build, or me, I'm going to build, and I hope I do this correctly, from two pieces of public information. First, the authorized server address, and the client's client ID, which isn't secret, the same way any like sign in with Google, sign in with X button exposes its client ID. All right, yeah, authorized. So this is going to be the link that Alice is going to phish Bob with, and Bob is going to click on because it's going to be sent in his mail saying, oh, click, click this link. You need to update something. And Bob's just going to see a harmless link, which is going to be a familiar link because, oh, it's localhost 3001. I know what that is. That's safe. It's fine to click on. It's like if something started with unsw.something.au and, no, we're not going to do the percent. We just say HTTP localhost. Yeah, it's basically going to be a phishing attack. Bob is not going to suspect anything. It's basically like this, the webhooking thing, CTFs, where you disguise the link by making it start with a safe-looking link. But in reality, it doesn't lead to that safe-looking link. And we'll add the scope here, being profile and state. Let's just make that Alice CSRF token. Oh. Okay, so yeah, redirect URI is URL encoded as we want. That decodes to Alice's server. I hope I did this correctly. And nothing else about this URL is suspicious looking. That's what makes it dangerous. And now Bob is going to be pasting this link that he, like that. Oh, and actually says redirect URI could not be trusted. Let's go see if our authorization server saved properly. Okay, so after some debugging, I did actually find the issue. It turns out that I just typed in the domain name wrong, which is pretty silly. And we don't need the special like percentage URL encoded representations of these. Yeah, so I believe this should now work. And let's try it one more time. We'll run all of our servers. And we will copy and paste this link we've crafted. And we'll paste it in. And, oh, I mean, this doesn't matter. But boom, just like that. Now it works. And now Bob clicked this link from Alice, who he thought was perfectly normal, and he's going to be redirected to the sign-in screen, which again, he thinks is normal because he's familiar with the sign-in screen for the third-party app and for this student portal. So yeah, Bob is just going to log in as Bob, victim123, continue to consent, and he's going to see this approve access, just profile. They only need access to his profile, nothing fishy, nothing showing up yet. But once he approves, Bob just approved. His password never leaving the server though. He saw a real consent screen, clicked approve, and it just says this page isn't available right now. So Bob is going to be like, oh, weird. I'll just try again. But it's too late. He's already on the localhost with the captcha code in the browser and the state showing Alice a CSRF token. So now let's go to our terminal, and what we notice is that we got our captchas here. We got our captchas incoming request on Alice's server, and Alice received the captcha code, basically this section. And for simplicity, I also wrote stolen authorization code, which is right here, bound to Bob. So now we can exchange this manually using our link we crafted earlier, which is this. And we just need to replace our, let's copy this again. We just need to replace our input stolen authorization code here with the actual stolen authorization we code. And we're going to be running this command in the terminal. There we go, in just a new terminal. It can be another one, but just for simplicity. Enter, and it got an error, of course. Okay, more debugging. Yep, so it looks like the issue is I misspelled authorize based on what my program used. This has kept messing me up because of the fact that when I generated the boilerplate of the server using Claude, it spells authorize with a Z, but I spell authorize with a S. So yeah, I had the grant type as authorization with a S, but it should be a Z to strictly match the code we have. And now this should work. Again, we're just going to demonstrate it one more time from the top. We'll run all three servers. Bob paste this link in that Alice sent. And I'm just going to be like, okay, yep, just update my account with that. Bob's going to put his password in and approve. Right? And page isn't available right now. And again, in the terminal, it pops up with our exchange it manually with blah, blah, blah. So we're going to use this command with our stolen authorization code we got. And this time we will swap the authorize to a Z. And again, do it in our capture server earlier too. Because yeah, we don't want to accidentally mislead ourselves like that. And we will input our stolen authorization code, which is right here, and paste it right in here. Also, this time around, unlike the CSRF attack I did, instead of like pasting the code, making another section for it, or like from the browser really quick, in a real life scenario, this code might just flicker, or it might like, you might need like iframes. So in a real attack, it'll show the code on the server like this, which I should have done for the CSRF demo, but again, it was just for show. So yeah, even if this doesn't show up or it flickers to some other page really quickly, like it does with CSRF, it will still get the capture code here with our command. All right, now let's run this command on the terminal, and boom. Now we have the access token for Bob. We now have Bob's access token. And yeah, just to show what we can do with this, which you can do a lot within the like server and etc. We're gonna copy the access token right here. And we can see that it is Bob's access token. We will get a new comment. This is Bob's access token. I should have just copied this part. And we have a we have our dashboard set up, localhost 3001, and this is going to be the link we use, with the access token being our token in here. So there we go. And if we actually paste this in, we can see what happens visually rather than just raw JSON. And yeah, Alice can just paste this in her own browser. And yeah, it says welcome back, Bob. So Alice now has control and is acting as Bob fully from her own browser, having never entered or gotten his password until the token expires or refreshes. And yeah, this again can now see Bob's dashboard and everything. Yep, as a wrap up, so one check in authorize.js, which was weakened in two places, a get and the post for handle authorize, was enough for complete account takeover with a valid request without any credential theft or network interception required. And that's what makes Redirect URI validation worth taking seriously. Because you get it slightly wrong and every other correct thing in the OAuth implementation doesn't matter anymore. So again, this is cybersecurity principles. A defender needs to defend every single possible vector, but an attacker just needs to find one. And the fix, again, as we discussed before, we just restore the previous line that we had in authorize.js, which is our redirect URI, client.redirect URI includes redirect URI, strict match. And yeah, that's according to IRC 6749312.3.1.2.3, if I believe correctly, instead of just comparing the same host name. So yeah, those are just real variants of the same bug. And again, this doesn't touch anything else, including single-use codes, expiry, state validation, the tokens, endpoints, own redirect URI recheck. Every other layer is just doing its job. It's just this one we can check that undoes all the others. All right. There you go. End the demo. Bit slow today.